How do intensive properties describe matter in thermodynamics? Imagine trying to describe a substance without knowing how much of it you have. It might seem tricky, but in thermodynamics, there are special ways to do this. These are called intensive properties. They are like fingerprints for matter because they stay the same no matter how much of the substance you have. For example, if you have a small cup of water or a large tank of it, the temperature and pressure are the same if the water is evenly heated and contained. That's because temperature and pressure are intensive properties. They tell us about the state of the matter itself, not its size or amount. Intensive properties are super useful because they let scientists and engineers understand and predict how matter behaves without needing to measure the entire system. If you know the temperature and pressure of a gas, you can figure out how it will react or change, no matter how much gas there is. This is because these properties are independent of the system's size. They are like a snapshot of the matter's condition. Another example is density, which is how much mass is packed into a certain volume. Density is an intensive property because it is calculated by dividing the mass by the volume. Whether you have a small sample or a large one, the density stays the same if the material is uniform. This helps in identifying materials and understanding their behavior. Other examples include melting point, boiling point, and refractive index. These are all properties that do not change with the amount of material. Specific heat capacity is another one, which tells us how much energy is needed to raise the temperature of a unit mass of a substance by 1 degree. In practical terms, knowing these properties allows us to control processes and design systems efficiently. For example, in engines or refrigerators, knowing the pressure and temperature of gases helps us predict how they will expand or contract. This way, we can optimize performance without needing to know exactly how much gas is involved. To sum up, intensive properties describe matter in thermodynamics by providing consistent, size-independent measures of its condition. They help us understand, predict, and control physical systems easily and accurately. These properties are the key to understanding the state of matter, no matter how big or small the system is.